Good afternoon, guys. Sorry I wasn't here in class today to go through this stuff, but I didn't want you to fall behind, so I went ahead and created a video so that you can stay on top of things and we didn't have to fall behind today, and I just give you some extra practice to do on this day. So I have this video to go through. It is also linked on the class calendar so that if you fall behind, you can always watch it on your own time. But I'm going to be writing stuff down at the same time as you, so hopefully you'll be able to keep up. But again, you could always go back later or compare notes with a friend once you're done. We are on page 30 in your notes, so hopefully you did that first. Hopefully you already have page 30 open, otherwise start flipping pages. But we're talking about angles still, but it's certain angles that occur when you end up having two parallel lines and what's called a transversal. So the first thing on page 30 is the word transversal. So a transversal is a type of line, but it's a specific type of line that intersects two or more coplanar lines at two distinct points. So you can see in this picture on this page, you have two lines. They're going to end up being parallel, and T is the transversal. It is cutting through them, and it's doing it at two different dots. That's the important thing about a transversal. Now, this one just has two lines. We'll eventually get pictures that have more than just these two lines in a transversal, but that's the key thing, is it's the one that's doing the cutting. You'll notice that when I drew the transversal in, I created 8 different angles, and there are certain relationships that are important to know about those 8 angles. The first one is called alternate interior angles. We're on the top left corner here. These are when you have alternate sides of your angles are on alternate sides of the transversal. So this is describing its location. So again, the two angles are on alternate, so different sides of the transversal. And it's also alternate interior. The interior is describing its location with respect to the parallel lines. They are interior, these are inside the parallel lines. So in our picture, we need to be inside these parallel lines. That's traced poorly, but whatever. So you cannot be outside. You cannot be 1 or 2. You cannot be 7 or 8. They need to be on different sides of the transversal, and I also need to put on here that they are not adjacent angles. They're not next to each other. So don't tell me angle 3 and angle 4. You can use angle 3, but it would pair with angle 6. That way you're on alternate sides of the transversal. You hopped across this line, but you ended up still being inside the parallel lines. So an example would be angle 3 and angle 6. Another set of examples would be angle 4 and angle 5. You'll notice I'm putting the congruent symbol on this because an important property we're going to use a lot is that alternate interior angles have measures that are congruent. They're going to be equal. So again, alternate sides of the transversal inside the parallel lines. Really similar to that on the right-hand side is alternate exterior angles. You're still going to be on alternate sides of the transversal. That's why we called them alternate. But now you have the label of exterior angles. This means these angles have to be outside the parallel lines. And again, we need to throw in here that these are non-adjacent angles. So different sides of the transversal. You need to name one angle from one side of this line and one from the other. And they need to be outside the parallel line. So don't name me any of 3, 4, 5, 6 this time. So an example could be 1, not adjacent to it, but on the opposite side would be 8. So angle 1 and angle 8. Likewise, angle 2 and angle 7. And as was true for the alternate exterior, alternate interior angles are also congruent. They're going to have the same measure. So we have alternate interior, we have alternate exterior, and then smack dab in the middle of your notes are the corresponding angles. These ones are kind of hard to fully define, so I'll kind of put a few things on here. One of the key differences though, these ones are on the same side of the transversal. If you've kind of already read the other little rectangles on this page, later we're going to have same side interior. Later we're going to have same side exterior. These ones aren't either of those. So while they're on the same side of the transversal, one of the angle in the pair will be interior. One of the angle in the pair will be exterior. And again, none of these angles that we're labeling are adjacent to each other. So that's one way you can kind of reason it out and find which one these are. The other thing is corresponding angles, they're in essentially the same spot in the intersection. I'm putting it in quotes because it's like relative, the same position. So for example, if I start with angle 1, I need to stay on the same side of this transversal, so I can only say either 3, 5, or 7. They need to not be adjacent, so I can't say 3. And one needs to be interior, one needs to be exterior. Well, one's outside these lines, so I can't say 7 because 7's also outside. Therefore, 5 would be its pair. And if you kind of look at the setup of this of like left, right, bottom left, bottom right, 5 is also in the top left, just like 1 is in the top left. That's what I mean when I say same spot. But we do have then angle 1 being congruent to angle 5, because if you have parallel lines, your corresponding angles will be congruent because they're in the same spot. If you can picture like taking scissors and cutting these angle sets apart right here, and if you pick these 4 numbers up and drop them on top of these 4 numbers, 1 lands on top of 5, therefore 1 and 5 are corresponding. 2 lands on top of 6, therefore angle 2 corresponds and is congruent to angle 6. 3 lands on 7, and 4 lands on 8. So corresponding angles, sometimes they're hard for people to get used to finding, but you can think of it the same spot. You can also think of it as one interior, one exterior, same side of the transversal, all that good stuff. So another one of the new ones on the left-hand side of your paper, same side interior angles. Well, we are really creative in math, and we called them same side because they're on the same side of the transversal. Wow. And as lame as the naming is, it really is helpful that it's in the name of how to find it. And again, we already used interior earlier. Same rule, these are on the inside of the parallel lines. Now, technically these also can't be adjacent, but honestly there's no way to fulfill these first 2 things and think they could be adjacent, so I'm just not going to write that one down. Same side of the transversal, inside the lines. Well, if I'm inside the lines, that rules those 4 out. Same side of the transversal, that either leaves me 3 pairing with 5 or 4 pairing with 6. These ones are not congruent though. They are supplementary. Meaning, when I add their measures together, the measure of angle 3 plus the measure of angle 5, I'm going to get 180 degrees. Ooh, sorry. When I add the measure of angle 4 with the measure of angle 6, I'm going to get 180 degrees because they are supplementary. Sorry. So then going across from that, same side exterior angles. Hopefully you're seeing the pattern of what keeps happening. But these are on the same side of the transversal. But now they're outside your parallel lines. Sorry. Still not adjacent, still not possible for this one, and still So if I have to be outside the parallel lines but on the same side of that transversal, that means I could take the measure of angle 1, add it to the measure of angle 7, and I'm going to end up at 180 degrees. I could take the measure of angle 2 and add it to the measure of angle 8. I'm going to get 180 degrees. Now those are the new angle pairs that we're going to get used to identifying. There are technically still vertical angles in this picture. They're still linear pairs. And we need to make sure that you are not forgetting that they exist and there are rules about them. So vertical angles are still going to have congruent measures. They're still officially defined as angles whose sides are opposite rays. You're still going to find them by angles across from each other in an X shape, meaning angle 1 is across from angle 4. They're congruent. Angle 2 is across from angle 3, 6 and 7, 5 and 8. I'm not going to list them all because I'm not about to list all the linear pairs in this picture. But they are also supplementary, like the same side interior exterior angles. They are going to still make a line, so maybe measure of angle 1 makes a straight line with the measure of angle 2, therefore their measures are supplementary. But I also could have paired up 1 with 3. This is the only set of angle pairs that are adjacent. So many times on those others I said not adjacent, not adjacent, not adjacent. Linear pairs, 100% adjacent. So this is an important page. This has all our definitions. This has examples of it. We need to actually go practice using it. So that's not bad. So if you turn the page to page 31, here's an example of something you're going to get where it's using it. So I'm asking you to first look at angles 1 and 5, tell me the relationship, tell me if they're congruent or supplementary, and then find me other angles with this property. One key thing that's missing on this is really actually important. This actually only works for parallel lines. So if I'm putting these extra arrows on, it means they're parallel. If I didn't tell you that, technically you can't do the whole problem, but they're parallel. So 1 and 5, if I look where 1 is and I look where 5 is, I see that they're on the same side of this transversal, and I see that they're not adjacent, they're not vertical, they're not a linear pair, but they're on the same side of the transversal. So that automatically limits me down to same side interior, same side exterior, or corresponding. Well, angle 1 is between these two parallel lines. Angle 5 is not. Therefore, those are corresponding angles. They are in the same relative position to each other. They're both kind of in the bottom left of that intersection. And if they're corresponding angles, their measures are congruent. And there are a lot of other corresponding angles in this picture. The weird thing is there are 4 angles down here, but suddenly there are 6 up in this one, which can get confusing. Just be really careful with which ones you say are corresponding. If I only focus on transversal C, so I'm going to pretend line D doesn't exist. If line D doesn't exist, then technically this is one big angle. I'm not going to use 2 or 3. I'm not going to use 9 or 14. And I'm also not looking at this part of my picture. We just said that 1 lands in the same spot as 5, but 4 is in the top right-hand spot, and down at the other intersection, 13 is on the same side of that transversal, but is now inside the parallel lines. So another example would be 4 and 13. Now, I didn't use this intersection over here. I could have. If you want to have another example down of corresponding angles, you could use 9 and 8. I'm not saying these are the only other ones, but those are other ones. So now let's do the next one. I don't have any angles labeled, but they're going to be alternate interior angles. The moment I say interior, I've restricted you to only looking inside these lines. So these are off limits. And I need to be on different sides of the transversal. I didn't tell you which transversal to use. We're going to pick one. And because that's poorly traced. We haven't used D yet, so I'm going to use D. So I'm not looking over here temporarily. I need to be on different sides of this transversal. So if I start with 6 to go to the other side of the transversal and not be adjacent to it, I'm going to pair it with 9. They are on alternate sides of the transversal inside those parallel lines. And again, that's only if I look at that one transversal. I didn't have to look at that transversal. I could have looked at this transversal, but wow, my tracing skills are way off today, sorry. And I still need to be alternate, but still interior. So I'm gonna use 1 and 13. Technically speaking, 12 would have someone they're congruent to because of alternate interior, but 12 is congruent to 14 and 19. Since I don't have a way to name the whole thing, I'm just not gonna use that example. But they would be congruent when you find alternate interior angles. So then 4 and 5. I see 4 up here. 4 is using line C. It's also using line A. 5 is down here. It's using C again, which I already traced, and it's using line B. So I'm not using transversal D at all. 4 and 5 are on different sides of my transversal, so they're already going to be labeled as alternate something. They're not adjacent, they're on alternate sides of the transversal, and if I pay attention to those parallel lines, they are outside of them. Those are alternate exterior angles, which means they're congruent. There is another pair of alternate exterior angles in the picture, but you got to flip over to the other transversal to get to them. So alternate exteriors, I need to be outside these parallel lines, so don't look at these. And I need to flip sides, and if I pay attention to these angles up here, I don't want to have to say 3 and 4 because I don't want to add 2 numbered angles. So I'm going to use 2, and the angle that's alternate exterior with angle 2 is angle 8. Next is 1 and 12. So if I go find it, angle 1 is here using line A and using line C. Angle 12 is here, which uses C again, but it also uses B. So I've determined that D is useless again. 1 and 12 are on the same side of the transversal. They're not adjacent. And when I'm paying attention to it, they're both interior. These are same side interior angles, which means because my lines are parallel, their measures are supplementary to each other. The other set of same side interior angles in this picture, if you use your other transversal, would be 9 and 11. They're on the same side of transversal D. They are inside lines A and B. So then 3 and 14. If I trace my lines, 3 uses line D and line C. If I trace my rays, 14 uses C and D again. If you ever find yourself only ever using 2 lines to create your angles, you don't have anything that's new. I could have asked you what type of angles those were earlier this week, and you should have known that they're vertical angles. Don't forget that vertical angles exist. They're still congruent, and there's still lots more in this picture. There are 2 pairs over here and 2 pairs over here. I'm only going to name one of them, and I'm choosing to name angle 6 and angle 8. Far from the only ones in this picture. Likewise, there are a ton of linear pairs in this picture. There are any of the angles that are adjacent and make a straight angle. I'm not going to use any of these intersections, mostly just because all the adjacent ones don't immediately add up to 180. If I could combine multiple, I could, but that's too much work. So I'm just going to use the bottom intersections, and I'm choosing to use angle 12 and angle 13. And I also could have instead said angle 6 and angle 7. There's a lot more examples than that, all of which are supplementary. So a lot of examples, a lot of things looking at it, but the more you do it, the more you're going to get used to that relationship, and not all of them are going to be this complicated of a picture. Exhibit A. Number 3 that we're going to get into, which real quick, we're not going to do number 2. That's left over from previous year's notes. There are same side exterior angles in this picture. If you are curious which ones later on, if you want to go find them, angle 4 and angle 10 are same side exterior, as are angle 2 and angle 7. That question is a holdover for before we change that picture. So a lot of times you're going to get examples like this where you are given parallel lines and just asked to find measures of them using these relationships. So first of all, I could say angle 2 right now because they're vertical. I'm not saying angle 2 is not 100. There's just more than one way to get there, and you guys know how excited I get when there's more than one way to get an answer. So what I want to point out, angle 1 and angle 100 are on different sides of this transversal. So they're alternate something. They're inside those lines, meaning they're alternate interior angles. That means the measure of angle 1 is 100 degrees because alternate interior angles are congruent. And I already know angle 2 is 100. I know. But one of the reasons that it's 100 is because it's corresponding with angle 1. They're in the same relative position. They are congruent for lots of reasons, one of which is these corresponding angle pairs. So if I come over to B and do similar stuff, there's some corresponding angles here. 85 is in like the top left spot. If I stay on the same side of that transversal, but go outside the parallel lines this time, I can know that the measure of angle 3 is also 85 because corresponding angles are congruent. I can know that the measure of angle 1 is 85, partially because now I have vertical angles with 3, and also partially because this and this make an alternate interior angle pair, and alternate interior angles are congruent. And then 2 and 4 are going to be congruent to each other because they're alternate interior angles. So whatever one is, the other is going to be, and there are lots of ways to find it. If I stick with using this 85, angle 4 is on the same side of the transversal. It's not adjacent. It is interior. Therefore, they're same side interior angles, and same side interior angles are supplementary. Really similar for C. The measure of angle 1 is 135. Why? Because they're corresponding, same relative spot. That means the measure of angle 2 is 135, partially because it's vertical with 1 and because it's alternate exterior with angle 2. The measure of angle 3 is 135, partially because it's vertical with the original 135 and because it corresponds with angle 2. They're in the same relative spot, therefore they are congruent. And then the measure of angle 4 is 45. We have linear pairs, but you also would have same side interior angles here, therefore they are supplementary. Lots of ways to reason these problems out, but for those ones you're not actually telling me why they are. We are going to need that for this one because it's not like we have lots of angles that we can relate together. I just have to come up with this relationship. They're on the same side of the transversal. They're not adjacent. One's interior, one's exterior. Those are corresponding angles. Corresponding angles are congruent. So, because they're congruent, I will set this expression equal to this expression. And then I'm going to solve. I'm going to subtract 2x. I'm going to add 20. Therefore, x is 30. And then if I go to substitute it in, 2 times 30 is 60. 60 plus 40 is 100. 4 times 30 is 120. Minus 20 is 100. We are confirming, yes, they are corresponding. Yes, they are congruent to each other. B is a little more complicated because there's no direct relationship between this angle and this angle. Yes, they're alternate, but they're not both interior, they're not both exterior. It's kind of weird. So what I'm going to do is, well, there's a couple ways I could do this. I'm going to use vertical angles. So if 3x is here, 3x is here. So this move here is just because I found a pair of vertical angles. But now that the 3x is there, it's actually helpful because when I compare, let me change colors so that it hopefully doesn't confuse. When I compare this angle with this angle, I ended up with another set of corresponding angles. So because they're corresponding, their measures are congruent, I can set them equal. So 3x will equal to 2x minus 10. I'm going to subtract 2x. What am I doing wrong? Did you find my mistake before I did? Because I said 2x minus 10 is here, and it's not. There's clearly an arrow pointing here. I was trying to make it less confusing, and I made it worse. Not the first time I've done that to you guys. Sorry. It's actually this angle. So they're not corresponding. They're same side interior. I'm sorry. Sorry if you're screaming at the video that, oh no, you're doing it wrong, hey no. Sorry, that's my fault. Same side interiors are not congruent. They are supplementary. So this equal sign should have been a plus sign. They're adding up to 180. My bad. Combine like terms, addition property of equality, division property of equality, we get x is 38. And then you could substitute them in, you'll find that they're supplementary. 3 times 38 gives this angle as 114. 2 times 38 minus 10 gives it the other angle is 66. So they are supplementary. I was trying to make them congruent, and they are not. Okay, so a couple more things on the back. Excuse me, gross. For this one, I have what we're presuming is probably a parallelogram, but it's not marked as a parallelogram, it's just marked as a trapezoid. We have 2 sets of parallel lines. We got one there, and we got one here. There are 2 transversals. The only one that's actually helpful is the one that's on the left, because it's the only one that actually have X's on it. So pretend like this part of your picture doesn't exist. It's not useful. You'll notice that these are on the same side of the transversal I drew. They're inside the the 2 parallel lines that were given to us. Therefore, we have same side interior angles. And we know that the measure of same side interior angles are going to be supplementary. So normally I would make you actually put the names of these angles. This picture doesn't have the names of the angles, so we're not going to have to do substitution. It's kind of a bad example because of that. It should have the names of the angles, but we're going to make do. So we're not going to actually say we're going to substitute. I'm going to combine like terms. So I'm going to get 2x minus 26 equals 180. I'm going to use the addition property of equality to get 2x equals 206. And because I am slowly starting to run out of time to finish this video before the bell rings and another class comes into my room, I'm going to abbreviate, even though you guys know I normally don't do that. So I'm finding that x is 103, and again, by abbreviating, which normally I don't want you to do, but that's from the division property of equality. So solving is the same as it always is, but sometimes now we're going to be starting with something other than angle addition, something other than angle bisector, something other than midpoint. We get a whole new set of things to start with. Sometimes I'm going to give you a picture like this where it's weird looking, but it always boils down to parallel lines and a transversal. Now this one also has x's and y's and z's, and I don't want to mix all those letters together, so I would like to get rid of some of them. I'm going to see if I can move, since I see x showing up more than once, I'm going to see if I can move my x's close by. So I'm looking at those parallel lines, and I'm going to use this transversal. No, I'm not going to use that. I'm going to use this better traced transversal. And when I do that, I see that 6/5 x plus 10 corresponds with z. Well, corresponding angles are equal. So I know 6/5 x plus 10 goes here, which is really helpful because that's a lot closer to the other x. So to get to the other x, I'm going to use the other set of parallel lines now. I'm going to use this guy, which again, sorry about my tracing skills, and this guy. I'm going to use this line again, but now this one's my transversal. You'll notice that my new location for 6/5 x plus 10, which is such a tongue twister, is now in the same spot as 2x minus 13. So because of corresponding angles, again, I have some congruent angles. 2x minus 13 is equal to that expression. I don't like fractions. I'm going to get them gone. I'm going to multiply everything by 5. 10x minus 65 is now equal to 6x plus 50. I'm going to subtract my 6x. I'm going to add my 65. I'm not going to write a decimal because we don't do that. So in proper fraction, x is 115 over 4, which means we can find z now because we said z was just 6/5 x plus 10. So now I'm going to have 6/5 times 115 over 4 plus 10. That's doable without a calculator, but with a calculator, you can real quickly get 89 over 2. So if this whole angle is 89 over 2, we can find y pretty easily because they were adjacent to each other and they're supplementary. So I could just say y plus 89 over 2 equals 180 and quickly get that y is 271 over 2. And I get that over 2 is not a bad decimal to have, but whatever, I didn't get a decimal. Last one. I know we're doing a lot, and I know I'm not here for it. Hopefully this is going okay. We'll have time on Monday to ask questions and get clarification. And again, this video is going to be on the class calendar so that you can go rewatch it in your free time, because I know over the weekend you're just dying to watch math videos. But anyway, I want to know, true or false, are 2 and 10 corresponding? So there's a lot of stuff in this picture. Focus on just the lines used to make the angles. So 2 is over here, 10 is down here. I'm not using line B at all. 2 and 10 are both same side. One's interior, one's exterior. They're in the same relative spot. That's a true statement. Next, I'm going to use, Next, I'm going to use angle 1 and angle 8. What I notice is I dot them. They're like right there. They're right next to each other. They're not same side interior angles. They're adjacent. Those are a linear pair, not same side exterior. 14 and 15 are supplementary. Key thing here being that they originally told us lines were parallel. Technically, you don't know any of these properties apply unless that's told to you, whatever. So 14 and 15 are supplementary. Let's see if that's true. They are on the inside of those 2 parallel lines. They're on the same side as D. That's true because same side interior angles are supplementary. So then I'm going to just keep working vertically. So I'm going to jump to part G, angle 3 and angle 14. So angle 3 is up here, made by lines B and C. Angle 14 is down here, made by lines B and D. They are on the same side of the transversal. They are outside the parallel lines. They are same side exterior angles. That's a true statement. The next one is also true because 7 and 2 are right there next to each other, meaning they're a linear pair. Linear pairs have to be supplementary by definition. 3 and 2. Well, I'm seeing they're on the same side of this transversal. They're inside my parallel lines. Same side interior angles are supplementary. 9 and 15. 9 and 15 are only using these 2 lines, but they're not adjacent. This time they're vertical. Vertical angles are congruent. We got a lot of true statements here. And then 4 and 11. 4 is here, 11's here. Weird thing about this one, they are alternate, on alternate sides of the transversal, but they're not alternate exterior. They're not alternate interior. They're kind of nothing. They're really similar to the example we just did on the flip side, 4B. They are really similar to this guy, where we have to move stuff to find any meaningful relationship. So if I move, let's say I'm going to move 11. I'm going to find the angle that corresponds with 11. 3 corresponds with 11. So I could have written an 11 here. Well, now it's just adjacent to 4. Now you have a linear pair, so it's true that they are supplementary. There's no specific name for the original 4 and 11, but their relationship will still be that those angles are supplementary. So give the homework a whirl. Watch this again if you need to. Talk to each other. I know it's the weekend. I know this is new stuff, and it stinks that I'm not here, but make the best of it, and we will do what we can on Monday to address any issues as we finish up more notes, just getting used to identifying these angle pairs. Good luck, and have a good weekend.